Good morning, students. My name is Fernando Lopez, and your mission for today is to learn what a base is and how to convert from one base to another. First, we're going to start with what is a base. A base is how many numbers are used in a number system. In the decimal number system that we use every day has 10 digits, from 0 to 9, and so it's base 10. We also have different type of bases. We have, for example, base 2 and base 16. Base 2 is also called binary system, so it uses digits that can only be 0 or 1. In the base 16, we have the hexadecimal system and uses digits from 0 to 15. But since we can't use the 10, 11, 12, 13, 14, and 15, for more practical uses, we use the letters A to F. One of the advantages that we have is that most common applications for the binary number systems can be found in computer technology. All computer language and programming is based on the two-digit number system using digital encoding. Digital encoding is the process of taking data and representing it with discrete bits of information. These discrete bits consist of the zeros and ones of the binary system. Base 16 corresponds to memory addressing in computers. For example, 1 byte is 2 hexadecimal digits, and it's more practical to take the address. We can see this memory addressing when we saw the class of pointers, and since they give garbage, we can see those kind of hexadecimal numbers. Now we're going to learn how to change bases. First, we're going to convert the 357 base 10 to the corresponding binary number. To do this conversion, I need to divide repeatedly by the base we want to have to change, keeping track of the remainder as I go. As you can see, we have the 357 over here, and we divide it by 2. We keep of the remainder there is 1. Then, the result of the division, we divide it again by 2, and we keep track of the remainder that is 0. We go on and on until we hit the 1. These reminders tell me what the binary number is. I read the number from around the outside of the division, starting on top and wrapping my way around down the right hand side. So now we have that 357 converts to 1, 0, 1, 1, 0, 0, 1, 0, and finally 1. Here's another example. Now we're going to convert the 63,933 base 10 to the corresponding hexadecimal number. I will divide repeatedly by 16, since it's the base we're going to use this time, keeping track of my remainder. Here we have the division. Divide by 16, the remainder is 13. Then what is left, we divide it again by 16, and the remainder is 11. Then what is left again by 16, we have 9, and the left is 15. Since 15 can be divided any times by 16, we left the 15 over there. Now the number will be 15, 9, 11, and 13. I cannot write the hexadecimal number as 15, 9, 11, 13 because this would be confusing and imprecise. So I will use the letters for the digits that are otherwise too large, letting F standing for 15, B standing for 11, and D standing for 13. So 63,933 converts to F9 BD base 16. Now we're going to do it the other way around. We want to change the base from base 2 to base 10. So we're going to convert the 1011000101 to the corresponding base 10 number. I will list the digits in order and count them off from the right, starting with 0. So we have the number right here on the top, and we count from the right to the left, starting with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8. The first row labeled as digits contains the digits from the binary number. The second row labeled numbering contains the power of the base corresponding to each digit. So to do this, we're going to multiply the 1 times the base 2 to the 8th power plus the next number 0 times 2 to the 7th power plus 1 times 2 to the 6th power plus 1, and so on and on. Here we will multiply 1 times 256, that is 2 to the 8th power, plus 0 times 128, that is 2 to the 7th power. We do it in each one of these ones. Now we got that we add the 256, the 64, the 32, the 4, and the 1. It gives you the 357, that is the result. So 10, 11, 0, 0, 1, 0, 1 converts to 357 base 10. Now we're going to do the same, but with the hexadecimal base. We're going to convert the F9BD to decimal notation. I will list the digits in order and count them off from the right, starting with 0, just like we did in the last example. We list the F9BD, so we list them as 0, 1, 2, 3. But actually it would be probably helpful to redo this, converting the alphabetical hexadecimal digits to the corresponding regular decimal values. So instead of the D we put 13, instead of B 11, and instead of F we put 15. Now we're going to do the same we did with the last one. We're going to multiply the number of the top times the base 16 to the 3rd power, plus 9 times 16 to the 2nd power, plus 11 times 16, and plus 13 times 16. We do this, we can use a calculator to help us. So we got the 15 times 4096 plus 9 times 256 plus 11 times 16 plus 13 times 1. We got this number, we add them, and we get that 63,933. So we got that F9BD is equal to 63,933, just like we did in the last time. We got in the last one. Now we're going to see a little example of decoding. Here we have a little program in C that helps us to change a number to any other base we want. First we have an array of digits, so we have the numbers from 0 to F, counting the A as 10, the B as 11, the C as 12, the D as 13, E 14, and F 15. Then we have an array of the reminders that we're going to get. We have the number, the base, and the index. Now we ask to the user the number and base they wish. We get those numbers. And in this loop, what we're going to do is get the reminder of the number and put it inside the array. We do this until it's different than 0. Until it's equal to 0. Now we're going to subtract 1 to the index so we can get in the last position of the array. And to print it, we're going to go backwards. So we're going to print the last position of the array of digit space, and we're going to get the number. Here are some of the examples that we got. So in the first example, you get the number desired base, that is 19 base 2, and we convert the number. If you want to do it, you can check it by hand, so you can practice some more. And in the next one, so we have 255 in base 16, it's FF. And the last one is at 789 to the base 8. It doesn't matter the base, the method that I taught you, it can do it with any other base, it doesn't matter. Just divide it by the number you want, or raise the power to the number you have. Well, that would be everything for me. Thank you guys for paying attention. I hope this helps you. Bye bye.